So we're going to be talking a little bit about the WhiteNFV, that is our distribution, but also about, as Francisco Javier mentioned, about containers and all our view about how things should move towards containers. I think that if we can make it interactive somehow, I know that it's more difficult in a remote session, but if at some point you have any questions, you don't need to wait until the end. Maybe you can ask me questions during the presentation, and at the end, I'm sure there will be some time for discussion. So I think it's super important to take the time to discuss and clarify every questions that you may have. Okay, so WhiteNFV Castelldefels is our third formal major release. It's a process we started 2 years ago in January 2018, where there was no formal WhiteNFV release, but we started to participate in the Etsy plug tests, a very good experience that allows providers of different components in the NFV architecture to interact with some other players and test compatibility. So at that point, we took OSM. OSM was an open source project. There was no formal distribution. We made some work to pack it in a software that was deployable during the Etsy plug test. And we got a lot of experience from the interactions we had with the different players in this industry. Later on, a year and a half ago, we released the first commercial distribution that was called Alcobendas. We named the versions after cities where we had the OSM meetings. So there was a meeting in Alcobendas that was also release A, based in OSM release 5. Then we had Barcelona, and recently, end of last year, we released Castelldefels, that is our third release, based on OSM release 7. What is the main focus of this release? Well, as you know, all NFV has been about moving from bare metal boxes to virtual machines. And that I think that OSM has been very successful on that. We today are positioned as the, I would say, the unique open source orchestrator able to deploy network services in Openstack or even in the public cloud. That was, I think we still have some leadership on that. However, everybody anticipate that the future will be more related to containers. So in release 7 and in Castelldefels, we are including for the first time a feature that will allow operators to deploy not VNFs, but CNFs, containerized network functions. And it's basically the same concept that enabling network functions in virtual machines on top of OpenStack or Amazon Web Services or VMware, but this time is related to deploy it in the format of containers. Obviously, at this point, the best option to orchestrate those containers is Kubernetes. So we are deploying specifically on top of Kubernetes, who could also be running on top of OpenStack. That's a very standard approach to run Kubernetes clusters in OpenStack virtual machines, but also you have the option to run OSM and CNFs in the public cloud, where you can find a number of cloud providers that can offer you a cluster created on demand in a few seconds. For managing the VNFs, we used to have a Juju. Juju is an execution environment as a piece of software from Canonical that allows to interact and control and manage the VNFs. Now, in the world of containers, we are keeping Juju, but also we are adding Helm. Helm is a new approach to manage containers, making it very easy. It's a different approach, not comparable to what Juju does. But it's very interesting because a lot of VNF vendors are planning to provide their VNFs or their CNFs as Helm charts. That's the new format of delivering software in Helm. So when we talk about Kubernetes and OSM, there is some confusion sometimes about if you are thinking on Kubernetes for deploying OSM or for deploying the CNFs, the containerized network functions. At this point, we support both. So you can deploy OSM as containers in Kubernetes. So the OSM will run in a containerized way. And for that, we use Ansible for deploying that in case of WhiteNFV. And then you have the option to have not one, but several other clusters where you can deploy containerized network functions by using Juju or by using Helm. And you can have also interaction between those CNFs with VNFs, creating hybrid network services that will allow you to integrate traditional VNFs with these more new CNFs and the same network service as you obviously will expect to make it more efficient. So let's talk a little bit about deploying OSM in Kubernetes. So what basically we do is there is a number of images that contain the different OSM components. We deploy that in a Kubernetes container that for reasons of high availability, we don't deploy in a single server, but we deploy that in a diverse setup where you have several instances and a number of physical machines. So the most simple configuration for a production environment is 3 virtual machines. On top of those 3 virtual machines, you create automatically with a WhiteNFV installer a Kubernetes cluster, and then you deploy the different containerized images of OSM in that cluster. And those 3 virtual machines are actually running on top of OpenStack that in addition are running in 3 different physical servers using what is called an anti-affinity policy, what means that we need to ensure that the 3 virtual machines are running in different physical servers. So that way, if there is any problem with a physical server, will only affect one of the virtual machines and a fraction of the total cluster. And we also deploy the different containers with an anti-affinity policy that means distribute all the replicas for the same component as much virtual machines is possible. So that way we have everything highly distributed, and any physical failure or logical failure or network failure will affect only a specific number of containers. And because Kubernetes is about distributed systems, that will have a very limited effect in the application. And why do we use the Kubernetes and why do we use Ansible for deploying OSM? Well, basically it's because what everybody else is using. Kubernetes is by far the most used and the fastest growing platform for containers deployment. And for configuration automation, the most popular tool these days is Ansible. So with this combination, we ensure to have a very standard deployment. We are not requiring you any specific tool for deploying OSM in production, but using basically what everybody else is using. Benefits of using containers, well, you know them, sub-second high availability and auto-healing. That's super important. Easy upgrades, the rolling upgrades, so you can manage in a very controlled way the upgrade from one version to the other with minimum effects in the service. And then you can decide how to deploy the different OSM components in different servers. And that's important because in most operators that are concerned about security, there is some practices that requires to separate things in layers so that if any component is exposed in security problem, it will only affect that specific component and that will not grant access to the attacker to the rest of the components. We also have a way to deploy WhiteNFV in a more simple format that is for testing or for development, that is in one single machine, in one single virtual machine, in one single server with a very minimum Kubernetes cluster that is functionally equivalent to the production environment, but it uses much less resources and make it feasible for, as I said, for testing or for development of tools and so on. Okay, let's talk about not deploying OSM. Let's assume that OSM is already deployed, WhiteNFV is deployed, but about VNFs versus CNFs. So normally, a network service will have a number of virtual network functions, and now we'll have a number of containerized network functions. VNFs are normally comprised by VDUs, and a VDU is basically a virtual machine. So you will have a VNF with 10 VDUs. It will mean that that VNF is 10 virtual machines. A VNF is not only one virtual machine, could have much more than that. In the case of the CNF, the whole CNF will be a Kubernetes cluster, meaning that each CNF has their own cluster with their own parameters, their own configuration that could be different from one vendor to the other. Within that cluster that is equivalent to the CNF, there will be a number of pods. The pods are the minimum Kubernetes deployment unit and is the component that's actually providing the service. Normally, the pod is equivalent to a container. It's not exactly that, but normally there is a very direct relationship. And so in that way, you will, if you have a hybrid network service that comprises VNFs and CNFs, you will have a number of virtual machines representing their VDUs and a number of pods running in different Kubernetes containers, and everything will be integrated by using the underlay network that will connect all the CNFs with the VNFs. That's a role of OSM, or of creating that network service and interconnecting all the components. So having that is very possible to have hybrid network services, and that's something that we have been experiencing a lot recently with some open source projects that deliver their functionality in the form of virtual machines and containers. So we have been doing a lot of experiences deploying that with Helm, for instance, but also with Juju and with different approaches. So Juju and Helm, people will think that will address the same problem, and they're very similar, but their theories or their concepts are different. So Juju is more aligned to the concepts, the day 0, day 1, day 2. But in Helm, that's not strictly valid. In Helm, you don't need to have those days, instantiation, configuration, and operation, because as a cloud-native application, every time you need to change application parameters, you can reinstantiate, you redeploy, and that's super fast in containers. So you don't need to deal with the concept of day 0, day 1, or day 2, although you can use it, but it's not necessary. Helm uses charts. That is basically is a template system that describe all the dependencies. So as you know, a Kubernetes application is a number of deployers. There is some descriptors, and could be a lot if the application is complex. What Helm does is to automate that, to create templates that will describe all those descriptors, so you don't need to pay attention to anything of those details, and you just can deploy a complex application by doing helm install and the application name. And that's super simple and super fast, because what will happen about that is that it will create the descriptors from the templates. You can specify your own variables to the templates so that you can customize the deployment. It doesn't need to be exactly the same in every environment. And then the Kubernetes cluster will download the container images and make it run. Super simple. They also have what is called a Helm Hub. Is a sort of store where you have a lot of charts that you can download and use. Actually, you don't need to download them. You just need to register the repository, and then you just do Helm install the name of the application. Helm will look it through the different repos and will deploy it automatically. Super simple, and that's something that is getting a lot of traction, not only in the IT world, but also in the operators and in VNF vendors. Most 5G cores are thought to be deployed with Helm. As far as we know, larger vendors are considering to provide their solutions for 5G by using this methodology. So it's super important to align with this. And again, it's something standard, super standard. We're not inventing anything else, anything new. Is something that is an industry standard. About our release calendar, so what we are doing is we're trying to align as much as possible to the formal OSM release. So every time there is a formal major release in OSM, we take 2, 3, 4 weeks maximum to release our equivalent release. It happened that like that for Castelldefels, that we released it early this year. And that's the idea that every time that there is a minor release, we also will release a maintenance release. And that's the case with OSM 7.0.1 that was released in February, and that we already released a second Castelldefels update, Castelldefels number 2. Roadmap for the future, well, we need to include more functionality about CNFs. This is just the beginning. There is much more requirements from operators to make it practical, easier to use, scalable, adaptable to what the vendors are also requiring. So it's super important to align with that. The second thing is that we are planning to implement our own WhiteNFV Helm chart so that the installation will be much simpler by using a standard mechanism. You will just need one command to deploy everything. So that's one of our objectives for the next release. We are going to have more integration with OpenStack, and this is super important because Kubernetes needs to integrate more efficiently with OpenStack. OpenStack is able to provide to the Kubernetes cluster with services like load balancing by using Octavia, storage backends by using Cinder, Swift, Manila, and many other services. So if we are deploying a Kubernetes cluster in the public cloud, there is some integrations with Google Cloud, with Amazon, and so on. If we deploy a Kubernetes cluster in OpenStack, we expect the same level of integration. So we're working on that, and we expect in the next release to have a much better integration with OpenStack. That is probably the platform that most operators will use for deploying OSM. More monitoring. We are already monitoring the network services, providing graphs and dashboards for performance. We are going to improve that much more. And also we are improving the system monitoring because in production you need much better metrics, and that's a special focus for us to provide operators all the information about their deployment. Security, we are moving all the sessions between components to SSL, and we are providing auditing of everything the users are doing so that the security teams could be in a position to understand what every user is doing on the platform. Some other interesting experiences that we are having with OSM, with OpenStack, and so on. We are working very closely with the Telecom Infra project to deploy with them very real NFV implementations. This is the case of the first OpenRAN deployment in Latin America. Is actually a Telefónica project called Internet para Todos. Was deployed in Peru with Parallel Wireless as the VNF vendor. And there, the objective is to provide coverage, mobile coverage, to users that don't have enough coverage in Peru. So this here is the distribution of the population. This here is the distribution of the network. The delta between them are the users with no coverage. So Telefónica with Facebook and some other players, Parallel Wireless, Whitestack, are deploying a access network virtualized, not a packet core, but an access network that's virtualized and is using all these concepts. We are also working with the Facebook connectivity team to deploy Magma. Magma is an open source packet core that interestingly has the two flavors that we have been talking about. Their orchestrator and federation gateway are containers. And then we have a number of edge devices that used to be bare metal servers. In their original design was just a computer running proprietary open source software from Facebook that manage the traffic, but we succeeded deploying that in OpenStack, virtualized with OSM and all of that. So very interesting example where we are using Helm charts for deploying the containers and Juju for deploying the VNFs, and everything is integrated. And we are also working with some other open source projects like Open5GS. They provide a complete 5G core, and we are also working with them, onboarding them to OSM so that we can use it in our demos, POCs, and projects. Finally, Whitestack and some other members of the TSC and the VNF onboarding task force is proposing a new model for creating what is called VNF catalogs. The idea is to have a structure for hosting VNFs in public catalogs or repositories in a way that the VNF publishers will be able to upload their VNFs to these repositories, and then users will be able to download them automatically from OSM. So if an OSM user is willing to test a PCRF or a DPI or any standard VNF, and they can find it in a repo, they can download it automatically, test it, see if it works for them, and finally use it. So we believe that creating repositories is super important because not only help us to pack things in a different way to create a better packaging system, but also help us to distribute things much faster than moving files our own. So that's basically my summary. Thank you very much.